Hi friends, in this video we are going to discuss about the load test of the DC motor, field test. We are going to conduct a test on DC series motor. The only test here which is load test. In load test we have two tests. One is the Hopkinson test, another one is the field test. But Hopkinson test is not applicable for series motor, but field test is applicable for series motor also. This is important here. Next one. What is next? Let's see here the motor and generator set. This is my motor, which having the armature resistance and back EMF and armature resistance are like this. And next one, where is my generator? This is my generator. Nothing but in field test also, like a regenerative test, we required two identical machines, which is costly. First of all, the disadvantage is costly. Clear? Right, sir. Next one. See here, this generator is connected to load. Again here we required a load. So this is again the increment in cost. One is the input requirement more. Next one is the cost also more, because here we required a load. For example, its output is taken as a voltage V. For example, here to know the voltage and voltmeter connected here, this is V2, the second voltmeter, and here the current taken as the ammeter. Here the current is taken as I2. This is my generator. And motor should be given by the supply. This is series motor, right? So here the current is taken as I1. This is given from the supply, is like this, and this is connected to field winding of my generator. This is very important. Here you should remember. See, in this condition, the voltage from here to here is taken as V1. From here to here is taken as V1. Nothing but the voltage across the motor. But from here to here we should taken as V3. V3 is the voltage across motor and the field winding of generator. This is the field winding of generator, RFG. This is the field winding of motor, series field winding, of course. This is generally the test, field test. Here we require two identical machines. One is the generator, one is the motor. So what's our cost increases? Next, here we required a load. What's our cost increases? And next one, input required is equals to no load losses of two machines plus the input required to compensate the load also. So the input requirement is very high compared to all other. As usually, accuracy also very high compared to all other. Accuracy high, input high, load requirement high, two identical machines, cost is high. All the things are very high for this. For Swinburne test, all the things are very less. For field test, all the things are very high. And here, wastage, power wastage also more. Maximum power wastage is there. So if the power wastage is more, temperature also more, so less time we have to take to complete this test. Within less time, we have to complete this test because more temperature. Why? Because more power wastage. That's why more temperature will develop here. This is simply about the field test. Here, V1 is the voltage across armature of the motor plus field winding of the motor, V1. What is V3? V3 is equals to V1 plus field winding of the generator. Voltage across V1, nothing but armature and field winding of motor plus what is the field winding of generator. Here, very important thing is that, here the field winding of generator connected in series to the generally the field winding of generator connected in series to the armature of the generator, but here that is not correct. In series to the armature winding of motor. This is very important thing here. Armature winding of motor. The series field winding of generator which is there, that is connected in series to the armature winding of my motor. This is very important thing in this test. Okay, so simply the field winding of generator connected in series to the armature winding of my motor. That's simple. So this test conducted on DC series motor. Be careful. Now, what is the total input here required? The total input required is VI1. For example, here take V1. V1 is the voltage across the motor. But here V3 I am taking, which is V3. V3 is the total voltage. So V3I1 is the total voltage, total power required. And what is the total output? Total output is the V2I2. V2I2 total output. V3I1 is the total input. Total output minus total input is equals to losses. Total input minus total output is equals to losses. Which losses, sir? Stray losses plus, tell me, yeah, armature of motor losses. Next, armature of generator losses, but this is not included here. And what is next? What is next, sir? Tell me. In this method, losses, in this losses equals to stray losses plus armature of the motor, series field winding losses. What is the series field winding current? Here I1 is the current for all these. So no need to take IAM, simply I1 square RAM, I1 square IFM plus I1 square RFG. This is the losses. Total input minus total output is equals to losses. What is the total input? V3I1 minus V2I2. Losses is equals to stray losses plus I1 square RAM, I1 square RFM and I1 square RFG. From this we have to calculate the stray losses. How we can get the stray losses? Stray losses is equals to total losses, nothing but V3I1 minus V2I2. Total losses minus this losses. What is that? I1 square RAM plus RFM plus RFG. This is simply the stray losses what we have to require. This is simply the stray losses. Total input minus total losses minus this losses gives us the stray losses. From this also again, what is the stray losses of motor? The stray losses of motor is equals to Ws by 2. What is stray losses of generator? Is equals to Ws by 2. In both the cases, stray losses is equals to Ws by 2. This is simply what is the procedure of field test. Here the field winding of generator connected in series to the armature winding of motor. You should remember this one. Right. What is efficiency of my motor? Tell me. Efficiency of motor is equals to Input minus losses by input. What is the input for motor input? I am not asking total input. If you want to total input, this is the total input. This is the total output. Total output. But I want motor input. Motor input by motor input minus losses. Sorry. Motor input minus losses by motor input. Motor nothing but series field winding and armature nothing but only V1. So the efficiency of motor is equals to V1 I1. V1 I1 minus losses is there, right? V1 I1 minus, what are the losses? I1 square into RAM plus RFM plus stray losses. This is the losses. What is that, sir? V1 I1 is the input. I1 square into motor armature losses, field losses, and apart from this, we have a stray losses also. Stray losses. This is simply the losses. Input minus losses by input. Very simple question. V1 I1 minus I1 square R plus RSC and stray losses by input. This is efficiency of my motor, right? What is efficiency of generator? Efficiency of generator is nothing but output by output plus losses. What is the output, sir? Output of the generator is V2 I2 upon output plus losses V2 I2 plus I1 square RFG plus I2 square RAG plus stray losses. This is what? My efficiency of generator. This is what? Efficiency of motor. You have to observe R1 square RFG because in this current is I1. Always in this current is I1. But in this, the current is I2. That's why I2 square RAG. I1 square RFG, I2 square RAG plus stray losses. This is the output and this is the input. For motor input, for generator output. This is what the field test. In this, accuracy is more, cost is more, input requirement is more, temperature is more, power wastage is more, and only one that we have to complete within less time is the less. Are you clear? This is the second test in load test. So load test Hopkinson completed and next one is field test is also completed. This is simply about the DC motor testing. Is it clear? Right? Thank you.